Good day, class. So for our lesson today, we will be discussing EE1 or the DC circuits. Is the introduction to electrical circuits, specifically for DC circuits. So for lesson 1, our topic will be units associated with basic electrical quantities. So andyan yung charge, force, energy, and power. So by the way, I'm Engineer Christian Averion, an electrical engineer. So let's start. These are the quantities that we will be using in this subject. So, these are all SI units. Ano nga ba ang SI unit? So, SI unit is the system of units used in engineering and science. So, it is the international system of units, usually abbreviated to SI units. This was introduced in 1960 and is now adopted by majority of countries as the official system of measurement. So, sa ating subject, ito yung ating gagamitin. SI units tayo. Sample quantity. We have length. The unit is in meter. Mass, kilogram. Time, in seconds. Electric current, ampere. Thermodynamic temperature, Kelvin. Luminous intensity, candela. And amount of substance, mole. So, unang lesson natin is about charge. So, what is charge? Ano nga ba yung charge? The unit of charge is coulomb or C, where 1 coulomb is 1 ampere second. Or 1 C, let me highlight it. This one. 1 C is equals to 1 C is equals to 6.24 times 10 raised to 18 electrons. So the coulomb is defined as the quantity of electricity which flows past a given point in an electric circuit when a current of 1 ampere is maintained for 1 second. Thus, charge is in coulombs. So this is the formula for coulombs. Please write it down. Q is equals to IT, where I is the current in amperes and T is the time in seconds. So remember the units. The I is in amperes. It should be always in amperes. And T is always in seconds. So the I is amperes, SI unit yun. And time is in seconds, which is in SI unit. So let's have a problem number 1. Ito yung example natin. First example. If a current of 5 amperes flows for 2 minutes, find the quantity of electricity transferred. So, we are looking for Q, which is the electricity transferred. Electricity transferred. So, the formula for Q is equals to I times T. QIT. So, we have I, which is 5 amperes. And T, which is 2 minutes. As I said earlier, it should be always in SI unit. So, current is already in ampere, so we should convert 2 minutes into seconds. 2 minutes times 60 seconds. 60 seconds over 2 minutes. 1. Cancel natin to. So, 2 times 60 is 120 seconds. So, that should be it. Q is equals to 5 ampere times 120 seconds. So, the answer is 600. Again, the unit of Q is coulomb. 600 C. That's a simple question. So let's proceed in the second topic. Force. The unit of force is the Newton. Again, Newton, where 1 Newton is 1 kilogram meter per second squared. The Newton is defined as the force which, when applied to a mass of 1 kilogram, gives it an acceleration of 1 meter per second squared. Thus, force in Newton is equals to F equals to ma. So, force is equals to mass times acceleration. So, again, m should be in as a unit, so it should be in kilograms. And a acceleration is meters per second squared. We can say that 1 Newton is equals to kilogram meter per second squared. That is the breakdown unit of Newton. Kilogram meter per second squared. So, gravitational force or weight is mg or mass times gravity, where g is 9.81 meter per second squared. So, we will be using this a lot of times. G is 9.81 meter per second squared in SI unit. So, force is done. Next topic. We have problem number 2. Sample problem for force. A mass of 500 grams is accelerated at 2 meters per second squared by a force. Determine the force needed. So, we are looking for the force. Again, F is equals to mass times acceleration. A mass of 500 grams. Again, as a unit, the mass should be in kilograms. And acceleration is already at meter per second squared. So, okay na tayo sa acceleration. Convert muna natin. So, 5,000 grams times 1 kilogram over 1,000 grams. So, simple. Equals to 5 kilograms. So, F equals to ma. F is equals to mass of 5 kilogram multiplied by 2 meter per second squared. So, F is equals to 10 kilogram meter per second squared. Since this is the breakdown unit of Newton, we can also say that the force is equals to 10 newtons. That's it for sample problem number 2 for force. Okay, then sample problem number 3. Again for force. Find the force acting vertically downwards on a mass of 200 grams attached to a wire. So we are looking for the force. Mass times acceleration. Find the force acting downwards on a mass of 200 grams attached to a wire. So, we are looking for force, diba? We are looking for force. Now, we have mass. Where is the acceleration? Nasaan yung acceleration natin? Since this is acting vertically downwards, which means that the acceleration acting on the object is the acceleration due to gravity, which is G is equals to 9.81 meter per second squared. This one is the acceleration due to gravity. So F is also equals to mg. So we have the m of 200 grams, which we need to convert in kilograms, and g, which is the the acceleration due to gravity, which is 9.81 meter per second squared. Okay, so direct conversion natin yung grams, which is 200 grams is equals to 0.2 kilograms times G of 9.81 meters per second squared. The answer should be, calculator lang, 0.2 times 9.81 is equals to 1.962 Newton or kilogram meter per second squared. That is for problem number 3. Again, if the force is acting vertically downwards, meaning we have a acceleration due to gravity. So, huwag malilito. Pag nawala yung acceleration, maybe it's the acceleration due to gravity. So, next topic will be about energy. So, the unit of work or energy is the joule, where 1 joule is 1 Newton meter. So, the joule is defined as the work done or energy transferred when a force of 1 Newton is exerted through a distance of 1 meter in the direction of the force. Thus, the work done on a body is in joules. Again, joules breakdown unit is Newton meter. That is the breakdown unit of joules. And work is equals to Fs, or force in newtons times S in distance. And the distance is in meters. Force as a unit ng force is Newton. As a unit of distance is meters. And as a unit of work is joule. Okay, remember this formula. W is equals to Fs. So next one is power. The unit of power is watt. So where 1 watt is 1 joule per second. Power is defined as the rate of doing work or transferring energy. Thus, power is in watts. So this is the formula for watts. P is equals to W over T. W is work done or energy transferred in joules. And T is time in seconds. And P, power, is in watts. So breakdown unit of watt is joule per seconds. This is the breakdown unit for watts. Okay? So remember, power is in watts. So let's go with sample problem number 4. A portable machine requires a force of 200 newtons to move it. How much work is done if the machine is moved 20 meters? And what average power is utilized if the movement takes 25 seconds? So, first, we need to find the work. How much work is done? The formula for work is W equals to F S. And we have a force of 200 newtons. Ito yung F. Next, S. If the machine is moved 20 meters and the average power is utilized if the movement takes 25 seconds. S is the distance in meters, which is 20 meters. If F is equals to 200 newtons and S is equals to 20 meters, so W is equals to 200 newtons multiplied by 20 meters. And watts is equals to 200 times 20 Newton meter is 4,000 Newton meter or 4,000 joules. But what would be the correct answer? So the correct answer would be work is equals to 4 kilojoules. Okay, so we found the work done. Next, we need to find the average power utilized if the movement takes 25 seconds. So we need to find power. So power is equals to, let's recall, W over T. Power is 4,000 joules and T is 25 seconds. So P is equals to 4,000 joules or over by 25 seconds. So our P in watts is equals to 160 joules per seconds. And joule per seconds is watts. So 160 watts. Next one. Next sample problem is sample problem number 5. A mass of 1,000 kg is raised through a height of 10 meters in 20 seconds. What is A, the work done, and B, the power developed? Work done is W equals to F times S. We have a distance of 10 meters. Do we have a force? No, but we have a mass. So we need to find F. And F is equals to mass times acceleration. Do we have a acceleration? Do we have a meter per second squared unit? Wala. So, let's look at the problem. It says that the mass is raised through a height of 10 meters. Through a height. Ibig sabihin, there is a vertical variable or a acceleration due to gravity, which is 9.81 meter per second squared. That is the acceleration due to gravity. So F equals to M times. So F is equals to M times G. So F equals to M times G. F is equals to mass of 1,000 kilograms multiply by 9.81 meter per second squared. So we have a total force of 9,810 newtons. So that is our force. But we are not looking for the force. We are looking for the work done. So we have the force. Now we can solve for the work. So W is equals to F, which is 9,810 newtons multiplied by S, which is 10 meters. So our work done is 98,100 joule. So convert lang natin. So we have work is equals to 98.1 kilojoules. That would be the answer. Next, let's find the power developed. Power developed is P which is W over T. So P is equals to the work 98,100 joule over time in seconds, which is 20 seconds. So P is equals to 4,905 joules per seconds, or P is equals to 4.905 kilowatts. Okay, so that is our problem number 5. Okay, so that would be all for our first lesson. So these are practice questions, practice exercises. Make sure to answer it after this lesson. The PowerPoint will be available online, and so please see the instructions below kung paano madadownload or paano ko maipapasa sa inyo yung PowerPoints. This is the end for our lesson number 1, EE1 lesson 1 or DC circuits. So see you on EE1 lesson 2. Thank you.